Today we're going to discuss the relationship between thermal energy, heat, and temperature. Many times people confuse these terms and think they are the same thing, but they each are slightly different, but they are all related to one another. The best way to explain the relationship between these concepts is to give a few examples. The definition of thermal energy is said to be the total amount of kinetic energy of the molecules in a system or an area. This means if we calculated all of the energy of the motion of every molecule in a particular system, we would have our thermal energy. So even though an object like an iceberg may seem cold, it still has a tremendous amount of thermal energy because the molecules that make up that iceberg are constantly in motion. Temperature, on the other hand, is defined as the average kinetic energy of a substance or a system. Average kinetic energy is basically a synonym for temperature. Okay, so temperature is a measure of the average kinetic energy of a substance or the particles in a substance and does not depend on the size or the type of the object. Whereas thermal energy is the total amount of kinetic energy of the molecules in a substance. So the size of the substance and the mass of the substance will have an effect on the total thermal energy of that substance or system. Heat is the transfer of energy from a higher kinetic energy towards a lower kinetic energy. In other words, heat moves from hot towards cold. Let's look at an example. If we had a glass of water at room temperature and we added a few ice cubes to it, and we asked you the question, do the ice cubes cool the water down or does the water warm the ice cubes? Well, your answer should be that the water is actually warming the ice cubes because the water molecules are moving faster as they bombard into the slower moving molecules of the ice. They cause the ice cubes to melt because the ice cubes are now absorbing the kinetic energy of the warmer water, and that's causing the molecules that make up the ice cubes to start moving faster and faster and faster until it reaches a state of equilibrium or balance. So in the end, the temperature of the liquid water will be lower. So the average kinetic energy has dropped because you've mixed together the ice, which has a lower average kinetic energy or temperature, with the water, which had a higher average kinetic energy or temperature. So the overall temperature of this system dropped because the temperature or average kinetic energy of the molecules has dropped, but the overall thermal energy has remained the same because the heat was transferred from the room temperature water into the frozen ice cubes and cause them to melt. Because remember, heat travels from the warmer molecules or the warmer area from hot to the colder area. Okay, an example of the relationship between thermal energy, heat, and temperature may be, let's take for instance a boiling pot of water in a room. A boiling pot of water in a cool room loses some of its thermal energy as heat flows from the boiling water into the room. Remember, all these molecules are in motion. So as the water cools, the molecules of the water start to slow down. They're not moving as fast as they lose their heat. Over the next few hours, the water will cool until it hits the same temperature as the room. So the water will have the same average kinetic energy of molecules as the room did. At the same time, as the water cools, the room is gaining the heat. So as the water loses thermal energy from the area of high temperature or hot to an area of cold temperature or low, so when the thermal energy in the boiling water is lost in the form of heat into the cooler room, the room gains the lost thermal energy from the water. So as the thermal energy of the boiling water is lost as heat into the room, moving from an area high temperature towards an area of lower temperature, the room gains the lost thermal energy from the H2O. But because the room is so much larger than the small pot of water, the temperature of the room only increases slightly. And it may be so little that people in the room don't even know it. You wouldn't even notice it. Objects that are touching each other that are at different temperatures will transfer their heat to try to become the same temperature. Although how much energy it takes to change the temperature of an object is based on what it's made out of. That's all we have for today. If you have any questions, please feel free to ask us as we circulate around the room. Have a good night.